Hello viewers and welcome to the channel. My name is Juan and I am an EEE student from PSB Coventry University. Today, I will be showcasing to you guys what AI could bring to the table in manufacturing production lines. As we all know now in this day and age, many manufacturing production lines have operators to stand in the downstream to visually inspect each product one by one. But we all know that this could be very tiring and taxing. So when these operators get tired, it will affect their judgment. What many manufacturing lines will do is that they will have automated visual inspection systems where the product will be feed through the cameras, there'll be lighting. One issue with this is that this lighting could be inconsistent, or there might be lag time between the cameras, or the surfaces of the product might have some small variances that these cameras could not detect. So this is where the AI idea of having a AI visual inspection system comes in. So I'll be showing to you the visual inspection system written by myself using AI to detect whether the units are passable or have to reject them. So over here we have the UI of the visual inspection system. Currently right now is operator is locked on, and with the operator locked on right now it's set that they cannot do anything other than log in to a higher user level. So let's go and do that and log in to the admin level. Okay, now we are in as an admin. One thing is that there is a console over here where all the entries or key inputs are locked in over here. So let's go ahead. Once you're logged in into the AI vision inspection system as the admin level, you are able to access the open function, which can open or select the models. Currently right now we are using the model A, so we'll go ahead with that. We have selected model A, and you can see over here that the status says that model A is not trained, so we are not able to proceed with the run mode, and the only option we have is to either close the model or to train it. So let's go ahead and train the model. When train mode is pressed, it will automatically bring you to the directory where you can choose the images. So for now we are going to be training the model, so we'll proceed with train images. Currently right now my data set is 100 images. I have 50 pass images and 50 fail images. So right now we love Coke, so we got to choose Coke as the main subject. So Coke will pass for this model train. So we'll go ahead and pass all the Coke images. And you can see that the train model button over here is disabled, and you are required to train every single, or you're supposed to label every single images before you can train the model. So let's go on ahead with it. In the case where you misclick labeling the images, like let's say we accidentally misclick the code as fail, which is not what we want, we can actually go back to the image and relabel them again. As you can see, just now the images that we have failed, we have went through and passed it again. So now it's passed already. Okay, now this is a different brand, so we'll go on ahead and put this as the fail image. Okay, and you'll see that now the train model button is enabled, and there's a prompt that says that the model is ready to train, and let's go on ahead with it. You can see training started, training in progress. The timer is counting how long it takes to train the model. Okay, the training is completed, and now we can see that model train for 100 images or 100 images complete. The total training duration taken was 41 seconds. So if you need to take statistics on how long it takes to train a model, it's recorded down over here, so you can see. And after we train the model, we can proceed to the run mode for the automated inspection. So let's go on with it. So go back, and you'll see that now the status actually changed to ready, and the run mode is enabled. So let's go and run the images with the run image. So now the image is being fed through the model to compare, and the model will predict whether the image is pass or fail. And you'll notice that now there's this unknown image. This unknown image is added in to be an example of what if a model surface is very subtly different from the other. We can see that the average confidence pass is at 99%, average confidence fail is at 99%, and the average confidence for unknown is at 57%. So what this means is actually that if we do not have this unknown category, the image here, which is the Mountain Dew, might fall into either a pass or a fail, which is not really correct. So this unknown category is added to counter with that measure. And now the inspection is complete. You can see that total images fed through is 120, 50 pass, 50 fail, 20 unknown. So how do we know that this is actually correct? We can actually pull up the files. All these images are saved over here. So we can go through them and check if it's right or wrong. So the past images are over here. So there's 50 Coke bottles over here, which is correct. And then for the fail images, there is 50 Pepsi bottles, which is also correct based on what we have trained. And then there's this unknown Mountain Dew bottle. There's 20 of them over here. And we can see that average cycle time took around 50 milliseconds per image. But you'll actually notice that when running, it actually took longer than what it should be, because the delay is on. This delay function is added so that we can visually see whether what we feed through the model is actually correct or wrong. As if we do not have the delay, it will run so fast that it wouldn't even load the image. We can take a look at that. So we turn off the delay and rerun. And there you go. It's so fast. It didn't even load the images. Average cycle time 25 milliseconds. So this is considered quite high speed and high accuracy. So I hope that going through this visual inspection system with the AI can help you guys to grasp what this AI can actually bring to the table in a manufacturing production scenario. Thank you guys and have a good one.